Chapter 9 is all about measurement. A lot of it is converting back and forth between different units. Whenever we're converting with units that you would see here in the United States, such as inches, feet, yards, and miles, we're going to use something called dimensional analysis, which means we're going to be just simply multiplying a bunch of fractions together every time. They're going to give you in the My Math Lab homework and on the test some conversions that we need to work with when we're multiplying those fractions together. So if we look near the top, the first equation they give to us, I'll label it with a 1 and circle it, is that there are 12 inches in a foot. The second conversion, the second equation they provide for us is that there are 3 feet equal to 1 yard. And the third one is that there are 5,280 feet equal to 1 mile. Now before we jump into that example, the strategy we're going to use is like when we're multiplying numbers and fractions normally. So for example, let's say that I have 2/5, I'm just making something up off the top of my head here, times 3/2. Only when we're multiplying fractions am I allowed to cancel any matches with these numbers on the top and bottom. So I see a 2 on the top of the first fraction and on the bottom of the second fraction. So I can cancel them down to 1, and I'm left with a 3 on the top and a 5 on the bottom. And sure enough, if I were to multiply 2/5 times 3/2, I would get 3/5. We're going to use that same strategy of canceling out numbers, but we're going to do it with words, with units. So like, for example, if I had inches times feet over inches, I could get rid of the unit inches. Same idea. Let me show you what I mean. So looking at our first example, it says to convert the following. So we actually have 3 questions, an A, B, and a C. Starting with part A, it says to convert 78 inches to feet. So if you have 78 inches, how many feet is that? Step 1, we got to game plan it out. So first we see if they gave us an equation with both inches and feet inside of it. And they did. Equation number 1 has both the units inches and feet. So we're going to be able to quickly convert. There are 2 different units, inches and feet, which means we need to draw 2 fractions. So I'm going to draw 2 fraction bars, and we're multiplying these every time. Whatever they give to you will be your first fraction. They give us 78 inches. 78, I'll abbreviate inches IN. If they don't give you a fraction, and most of the time they don't, we need to make it into a fraction, which is easy enough. I just put the number 78 over 1, and voila. It's now a fraction. So 78 inches over 1. Whatever they want you to convert to, they want us to convert to feet. That is going to go on the top of the last fraction every time. So I'll abbreviate feet FT. Now we're ready to go. We've set up the fractions. So as I strategize here, if I want to get rid of inches, because I only want to be left with feet, that means that there should be another inches on the bottom of that next fraction. That way we can use that strategy of canceling out the word inches, just like we can cancel out numbers. And as far as what numbers to fill in the last fraction with, well, that's when we use the equations that they provided for us. Remember, they told us already that there are 12 inches in a foot. So the number 12 goes next to the inches, 1 goes next to the foot, and now we just simply multiply across the numerators and denominators. So looking across the numerators, I have a 78 times 1 foot for 78 feet. On the bottom, I have 1 times 12 for 12. So now, Keep in mind, fraction bar means division. I just do 78 divided by 12 on my calculator. Yes, you're definitely going to want a calculator handy when you do the homework, when you take the test. In fact, you're going to want access to a calculator for the rest of this course. If you have a graphing calculator, even better for when we hit the probability and statistic chapters later on in the course. But 78 divided by 12 is going to give me 6.5 feet as the final answer. So 78 inches is the same as 6.5 feet. Let's try another one. Example B says to convert 17,160 feet to miles. So step one, let's get our multiplying fractions set up and ready to go. We first skim the equations they gave to us in the original question, and we ask ourselves, did they give us both units, feet and miles, within the same equation? If not, that's okay. It just means there's a little bit more work. Usually means there's just a third fraction that we're dealing with. But here, I'm looking at equation number 3 of the originals, and yeah, they gave us feet and miles. So that means we only need 2 fraction bars. Again, we have 2 units, feet and miles, to worry about, so 2 fraction bars. I draw my fraction bars in black again, get my times symbol ready to go. What they give to us, the 17,160 feet, is going to be the first fraction. Put it over 1 if it's not a number that's a fraction already. Whatever we want to convert into, miles this time, goes on the top of the last fraction. The abbreviation for miles is MI. Now we're ready for step 2, which is to fill in the remaining blank spots here. If I want to get rid of feet, that means that there needs to be another feet on the bottom of that second fraction so that we can slash it away. And we refer to that equation 3 up top for what numbers we fill in with. So next to miles, there is 1 mile for every 5,280 feet. Now we just multiply across the numerators and denominators. So on the top, we got 17,160 times 1 mile for 17,160 miles. In the denominators, we got 1 times 5,280 for 5,280. Divide out on your calculator, 17,160 divided by 5,280. And as you try that, you should be getting 3.25 miles as your final answer. So up until this point, each of these conversions, they've given us both units in the original question. Let's amp it up though a little bit. I'm going to erase just to give myself some room. But looking at part C, it says to convert 3 inches to yards. As I skim the original equations up top, I do not see inches and yards within the same exact equation. I see inches with feet, I see yards with feet, but that's it. So this means we're going to have to bring out a third fraction. We're still multiplying fractions whenever we're doing this dimensional analysis. But as I game plan this out, what I could do is I could go from inches to feet by using equation 1. And then once I have it in feet, then I could go from feet to yards using equation 2. Since we have 3 different units this time, inches, feet, and yards, we then need 3 total fraction bars. Always multiplying them to begin. Same setup as above. Whatever we're given, 3 inches goes with the first fraction. Put it over the number 1. What we want at the end, yards, goes on top of the last fraction. The abbreviation for yards is YD. Now step 2, we're ready to fill in all the blank spots. If in red I want to get rid of inches, that means inches is going to go on the bottom of the second fraction. And we're going to go from inches to feet, so feet is going to go on the top. And as you can see, that will successfully get rid of the word inches. Using equation 1 to fill in the numbers, there are 12 inches. 12 goes next to the inches for every 1 foot. Now with the blue pen, now that we have feet, we're going to go from feet to yards using equation 2. I got to get rid of feet by putting it on the bottom of the third fraction, and as you can see, that will cancel out the unit feet. Using the numbers from equation 2 on the top of the screen, there are 3 feet in 1 yard. So the hard part is done. Step 3, we multiply across the tops and bottoms. On top, I have 3 times 1 times 1 yard for 3 yards. On the bottoms, I have 1 times 12 times 3 for 36. So I'm going to do 3 divided by 36 on my calculator. And most likely, my math lab homework for this chapter anyway is going to say round to the nearest hundredth as needed. The 100th spot is 2 spots to the right of the decimal. So approximately, I'm going to use that approximate wave because it's a decimal that just keeps going. When you do 3 divided by 36 and you round 2 digits out, you should be getting 0.08 approximately yards as your final answer. The next slide deals with converting within the metric system. Most other countries outside of the United States use the metric system. So looking at the table that I've drawn at the top, and you're welcome to use this table for your test, by the way, on this chapter. I have already uploaded a formula sheet into your course. You're more than welcome to print that out and bring it with you to use on test day. But anyway, this table will be somewhere on that formula sheet, and I have all the prefixes for the metric system and the main units in this table. Going from left to right, you can see that I have kilo, hecto, deca. The main units I have abbreviated in the middle, MLG. I'll come back to that in a second. Deci, centi, and milli. So when you see one letter M, that stands for meters in the metric system, and we use meters to measure the length of items, the length. My cursive L represents liters, and we use liters to measure items of capacity. Use it to measure capacity. And my little g represents grams, which we use to measure weight. So if you put the prefixes kilo, hecto, deca, deci, centi, milli in front of an MLG, then we mush it all together, and that's how we read it out loud. Now the abbreviation for kilo is going to be just a K. The abbreviation for hecto will simply be an H. We have 2 D's, a deca and a deci. Deca will be DA, will be its abbreviation. Deci will just simply be 1D. Centi will be a C, and milli will be an M. So for example, I'll put EX to abbreviate example. If I saw an H coming before an M, I would read that out loud as a hectometer. As a hectometer. If I saw DA coming before a G, well, DA stands for deca, And the G stands for gram, so that would be a decagram is how I would read that out loud. If I saw mm, well, the first M would be for milli, and any M's on the end would be meter. So this would stand for, of course, millimeter, and so on and so forth. And this system is so much easier to convert with, so much quicker than the units we use here in the United States. We don't have to use those fractions. We don't have to do that unit fraction multiplying. It's still a type of dimensional analysis in that we're converting back and forth. But looking at the first example, it says to convert 8,000 meters to kilometers. So I write down what we're given. We're given 8,000 meters. Meters, the abbreviation is just 1M. And we point to what we're given on the table. So I'm given meters right here in the middle. And my job is to convert to kilometers. So if I want to go to kilo, looking at the prefix, you'll notice that that is 1, 2, 3 hops to the left from meters. So you just simply count the number of hops and you note the direction on the table and you move your decimal point the same number of hops in the same exact direction. So 8,000, the decimal point is going to be on the far right. If you don't see the decimal point, you can always safely assume it's on the far right. And I'm going to move it 3 hops to the left. Here we go. 1, 2, 3. Its new location, when I plunk it down, is right after the 8. So let me write this a little bit neater. So 8,000 meters is going to be the same as 8 kilometers. Let's try another one. It says now to convert 0.023 millimeters to meters. So you just write down what you're given. We want to go to meters. I'll go ahead and do this one in blue. You point to what you're given. You're given millimeters, so we're starting with milli this time. Starting with milli over here. And we want to convert to just regular meters. So that's going to be 1, 2, 3. Coincidentally, 3 hops to the left again. So looking at our current decimal point, we got to move 3 hops to the left. After the first hop, we run out of room. So just keep hopping to the left, but you're going to have to insert some zeros as you move to the left. So you get 0.00023 meters when you move 3 hops to the left. You could type in your answer like that into the My Math Lab homework. That would be okay. If you're in a science course, they would prefer you put a 0 in the whole number spot just to really emphasize the location of that decimal point though. But you should be getting 4 zeros and then a 2-3 meters as your final answer. Now, when you go to do your homework, if you click on Question Help, then View an Example, they're going to show you a completely different way to convert within the metric system using multiplication and division. That strategy works as well. So it's up to you. You can use this table visual like I've done on this slide, or do the multiplication and division like the View an Example instructs. Either way is perfectly fine. You're going to get the correct answer. On the next slide, we're converting back and forth between our system that you see in the US, the Old English system, we sometimes call it, and the metric system. Unfortunately, if you see any units that we use here in the States, that means you're going to have to go back to the very first slide strategy of using those fractions, of multiplying fractions again. Another clue that you're going to have to multiply fractions is whenever they give you the conversions in the original question. So if you look near the top of the screen, they give us 4 conversions this time. They say that 1 inch is equal to 2.54 centimeters. Equation 2, 1 foot is 30.48 centimeters. Equation 3, 1 yard is approximately 0.9 of a meter, or the abbreviation for approximately is that wavy symbol. So they might just do it like this with the abbreviations for yard and meters on the homework. And equation 4, 1 mile, mi for mile, is approximately 1.6 kilometers, km for kilometers. So looking at the first example, it says to convert 8 feet to centimeters. Thinking back to the first slide in this video, our first step is to skim the equations that they provide for us, and let's see if both feet and centimeters are within the same exact equation. If not, it's just going to be more fraction bars potentially to get the job done. So feet and centimeters is equation 2. They did give us both units in the same equation. So I'm only going to need 2 fraction bars. One to represent feet and one to represent centimeters. So I'm going to draw 2 fraction bars with the multiplication symbol. They gave us 8 feet to put with the first fraction, put it over 1. Our job is to convert to centimeters. So step 1, the setup step is done. Step 2, we want to get rid of feet. That means feet's going to have to go on the bottom of the last fraction. And the blank spots for the numbers, use the equation above. So there's 1 foot for every 30.48 centimeters using equation 2. Now step 3, multiply out. On top, 8 times 30.48 centimeters would be 243.84 centimeters. On the bottom, 1 times 1 is obviously 1. So I'm going to do 243.84 divided by 1, which is again 243.84 centimeters as the final answer to the first example on this slide. The next example shows why I had to type these examples up after we familiarized ourselves with the metric system, because it's a little bit trickier than it first appears. It says to convert 30 meters to inches. When you first skim all 4 of the original equations, you'll notice that there is no equation with meters and inches. We have inches and centimeters in equation 1 that I'll circle in blue here. And the only thing we have with meters, if I look at equation 3, has yards. But I don't have anything, if I were to go from meters to yards, I don't have an equation that would go from yards to inches, at least not on this screen. If you wanted to use the equation from slide 1, you could, that's one option. But what the homework would expect you to do, and probably the quickest strategy, is to break it up into 2 separate steps that really summarize well the previous 2 slides. So step 1, we can convert from meters to centimeters. And once we have centimeters, then I can use equation 1 to go from centimeters to inches. Meters and centimeters in step 1 are both metric system units. So when it's metric system to metric system, just think of the table on the previous slide. We had that meters was in the middle, and we had deci was 1 hop to the right, and then centi, the prefix, was another hop after that. So if I'm going from meters to centimeters, that means I have to move my decimal point 2 hops to the right. Well, that's easy enough. So 30 meters, I can safely assume the decimal point is currently sitting at the end of the number 30. And when I take that decimal point Let me change it to black, and I go 2 hops to the right. I'll just insert some zeros after I hop. So 30 meters is really the same as 3,000 centimeters. Step 2, now I can use equation 1 to go from 3,000 centimeters to inches, which is what we wanted all along. Whenever we're doing anything involving units you see here in the US, then it's fraction time. 2 different units, so 2 fraction bars. We got 3,000 centimeters, put it over the number 1. We want to convert to inches. If we want to get rid of centimeters, it has to go on the bottom of the last fraction. Use the numbers from equation 1 to fill in the blank spots. So there's 1 inch, according to equation 1, for every 2.54 centimeters. So now we multiply across the numerators and denominators. On top, I see 3,000 times 1 inch for 3,000 inches. On the bottom, 1 times 2.54 for 2.54. Now, fraction bar means divide. So we're going to take 3,000 inches on our calculators and divide that by 2.54. And it's a number that goes on for a while. Most likely the homework will say round to the nearest hundredth, 2 digits out. So that would be 1181.10. Or if it said nearest tenth, that'd be 1 digit out, which would just be 0.1. So nearest hundredth, 0.10. Nearest tenth would be 0.1. Let's go with nearest tenth for a change. And that's inches. Let me change that to an approximately symbol because I did have to round that. 1181.1 inches, final answer. So when you're going back and forth with metric system and our system here in the States, and you don't see both units in the original equations, see if you can use the metric system to go to what they have in the original equations. They didn't have meters, but they did have centimeters with inches. So that's what I did in step 1 as I went from meters to centimeters. Finally, they're going to have you on the homework convert back and forth with temperature scales. They're going to have you go back and forth between Fahrenheit and Celsius. So here are the 2 equations you would want to use for that. The first equation, F for Fahrenheit, and then I have C obviously for Celsius. But Fahrenheit equals 9/5 times Celsius plus 32 degrees. Honestly, it's just one equation, and all mathematicians did is that they solved for C and they rearranged that equation a little bit. So if you're going to take equation 1 and solve for C, you're going to get C equals 5/9 times the quantity, parentheses, F minus 32 degrees, close your parentheses. So looking at the first example, it says convert 50 degrees Celsius to degrees Fahrenheit. Whatever you want to convert into, that will tell you which version of the equation, 1 or 2, would be best to use. So if I want to get Fahrenheit, I should use the F equals equation. So that was F equals, if I bring down that equation, 9/5 times your Celsius plus 32 degrees, that little circular symbol up in the air, obviously. And here we go. I just simply, very algebra-ish, plug in what they gave me. So they gave me 50 degrees Celsius, so 50 goes into C. If you have a graphing calculator, you could just plug this all in one line and hit enter. If you don't have a calculator, keep in mind that 50 is over 1. And when this is all said and done, you should be getting 122 degrees Fahrenheit. Let me rewrite this a little bit larger. 122 degrees Fahrenheit if you typed it correctly into the calculator or did it correctly in your head. Let's try another one. It says now convert 59 degrees Fahrenheit to degrees Celsius. So now they want Celsius, so I'm going to use the C equals equation. So that was C equals 5/9, bring it down the equation, times parentheses F minus 32 degrees. Plug the 59 degrees Fahrenheit into F. So that's 5/9 times parentheses 59 minus 32. Again, if you have the graphing calculator, you can plug this all in, parentheses and all, and just simply hit enter. If you don't have the graphing calculator, you would want to do parentheses first, inside parentheses, that is first. So you would do the 59 minus the 32 first. Which would give you 27. And then take that 27 and multiply it by 5/9. When you do that, you should be getting 15 as the final answer, or 15 degrees Celsius.